Hey guys, welcome back to the shop. We are going to continue the machining for our swivel bolt that's going inside of our USA made Hardtail Vise. And today we're going to be over here on our Milltronics USA Ep.13 tool room mill. So I've got 3 of these guys ready to finish out. I've got a previous video where we used our CNC lathe to turn these guys. I have 3 of these that I'd like to finish. Hopefully we're going to have some success over here on our Milltronics. I've also got 4 right here, and I've got these dotted with a yellow paint marker right there. These are the practice sessions that I went through, just I believe it's 1018 cold rolled, and I've got 4 of them right here. I'm going to use 1 or 2 or maybe even more as a practice run and make sure that our program is right and make sure everything is going to be cutting to our specifications the way we want. The original bolts, this guy right here, they've got a slot in this guy, so you can use a screwdriver, a scale, or anything flat and narrow that fit in there to tighten this guy up. But I didn't want to do that right there. I actually wanted to make this look a little bit more like a traditional socket head bolt. So we're going to be machining it to be able to use this 5/8 Allen wrench, and hopefully we'll have a nice 5/8 hex inside there that we can use when we go to tighten this guy up. All right. And then to top it off, if everything goes well, I'm going to engrave the A-Bomb79 logo on that face there as well. So we still need to go ahead and finish getting our spacer set up. We'll show you that. So I am going to use this is a Vertex simple spacer with, I believe that's a 6-inch chuck on there. I think that's going to work fine. There's not a lot of heavy machining that's going to be done on this, but that would probably work pretty good even if we had to do a bunch of heavy milling on there. But before we get in here and get this set up, how about I take you in there to the computer? I'm going to give you a quick rundown in the Fusion 360 and show you the program that we wrote, and we can simulate it. That way you guys can see what this is going to look like, and then we can jump back over here to the machine. Okay, we got you back in here looking at the Fusion 360. So I want to again thank Kevin over at Mechanical Advantage for helping me and training me. He has been my teacher, and we're going through some of this Fusion 360 training every week for a couple of hours, and this is one of the projects that he was kind of guiding me along with there as well. All right, so thank you, Kevin. Be sure to check him out if you're looking for some Fusion 360 training. So this was where I last left you, looking at our lathe profiles that we were going to turn in the CNC lathe. So we'll go ahead and get you flipped around here. Let's see if I can get this flipped around. Let's go to our left side. There you go. And how about this angle right there? Yep, I think that looks pretty good. So that's you can see what this is going to look like. And what we'll do is we'll face it, drill it, mill it, and then it's going to chamfer it, and we'll do some engraving on there as well. All right. I'll go ahead and run you through a simulation so you can see what it'll actually look like. Simulate with machine. All right. So we'll start with a smaller face mill, and we're going to just deck it off, leaving about 15 thousandths on that face, because what I'd like to do is come back. This is a spiral pattern that we ended up finishing this with, just because I like the look of a spiral finish on there. And we're going to be using our Tungaloy Tung Force Rec to do this operation right there. I love that mill. It does such a great job. All right, now you can see the center of it. We're going to go in there with a 3/16 drill bit and just go through a peck drilling cycle. I can't recall what the exact depth is. It's somewhere around 5/8 deep, I believe. Let's speed this up just a little bit. And all right, going through here, do our peck cycle, and then after it's drilling, we're going to use a 1/4 inch in mill to do a 2D adaptive program here. After the 2D adaptive, we will do a 2D contour. That's that right there. Then a 2D chamfer, another chamfer on the outside, and then we're going to engrave it. It looks pretty good on the computer. Let's go out to the machine and see if we can make this actually happen. So this is going to be our fixture. We're going to use our simple spacer there. We're going to locate off of this jaw face right there for our Z. and then we're going to find the center of it, so I'll use another piece there, but we're just going to set our work piece in there just like that, down on the jaw, tighten it up, and begin the machining. So let's go ahead and get this set up. This is going to be our G54 work offset. Going in with our Renishaw probe. Wrong side. There we go. We'll go ahead and locate our Z first, which is going to be the top of those jaws. Okay, so we've got our Tool 99 installed, which is our Renishaw probe. We're going to go to hand wheel and an F11 probe operation. We're going to do single surface in the Z axis, G54 work offset. It looks like I've got it maybe a 1/4 inch above the part there, so we'll go negative 0.250. Our Z position is going to be 0 because that's how we designed our program. The top of those jaws is 0, so we're going to hit 0 there, and this should be good to go. Single surface Z, work offset. All right, let's hit it. Okay, to find the center, I've got this 1-inch gauge plug installed in there, and I've got it eyeballed right about in the middle of the part there. So we'll go ahead and bring our probe down, and we'll use our web selection and locate the center both off of X and Y directions. All right, back in hand wheel mode here. We're going to go back to probe, and then we're going to change the operation to web, and X-axis is fine. We'll do that first. So for the diameter, I said 1 inch, but that's actually a 977 gauge plug, so we'll put 0.977 on our width. G54, we want our X position to be 0. Additional probing, we don't need that. Probe must be positioned -3 above the web. Okay, we're ready to run it, hit cycle start. All right, so we've got X0 now. We'll go ahead and go back into our probe. We're just going to change this to Y-axis. Come on. Everything should be the same, 977 diameter. Y position we want 0. No additional depth. We're ready to run it and hit cycle start. We should be in the center of our chuck there now. Now I would like to use the bore cycle on that, or the bore operation, but I don't have a good part here in the shop that's got a good true OD and ID, or I'm sorry, a true OD and ID that's concentric. So that's why I was using something that I know had a good ground OD finish on it. So we're going to start off with one of these other practice pieces. This is the 1018 cold rolled material right there. We're just going to make sure our program is working good with these first. And I'll probably go ahead and machine all 4 of them once I know that this is running good. Hopefully we got it ready to roll right out of the box here. All right, so just snug that up good. And then we've got our lock handle right here, which I already had locked, so we'll just keep that locked there. All right, I think we're ready to go. I've already got my tools. I already installed them. Our 1/4 inch end mill, our drill bits, our center drill is ready for engraving, and our face mill is already set up too. All of our tools are ready to go. So I've got a new camera mount right here up on the spindle. We're going to give that a try, but as most of you guys know, trying to get footage inside these CNC machines with the coolant is always challenging. So I'm going to do the best I can to try to get a variety of different shots during this machining to ultimately try to give you something that you can, see pretty clearly on the video of the machining that's happening during the machining cycle. All right, so let's go. I am going to have to periodically pause the program and adjust our coolant nozzle because we're at different heights here on our tools, so I'll have to kind of raise or lower the pressure of the coolant to make sure it's hitting the tools as we get in there, okay? Right now it's just making sure, empty the spindle and press tool reset. We've already done that because we used our Renishaw probe there. So tool reset, cycle start. I'm gonna bring this down kind of gentle just to make sure that we're not gonna be crashing it or anything like that. The tool changer's having a home itself. Sometimes it does that. There we go. All right, I'm just bringing it down. I'm going to stop the feed once we get down here. Yep, okay. All right, let's give it a shot. When we get into our drilling, I'll turn the coolant on. All right, that looks good. All right, we're going to slow that down, the rapids. Let me get our coolant going. So that is a 3/16 high-speed steel drill bit. All right, so we'll go home with our pec drilling cycle now. Now what I can do is just toggle this coolant on and off periodically like this, and you can kind of see. I believe what I chose here is it drills down a 1/16 of an inch and then it comes up and retracts to clear the chips. It looks like it's working good. I wonder if it'll make a difference if I turn this work light off. It looks really blown out on that GoPro screen there. We'll probably try it with and without, that way I can see how the video looks in editing. We'll go ahead and leave that light on for this one, and then maybe we'll try one without that work light on. All right, tool change to, now we're gonna go to our 1/4 inch end mill. Sorry, gotta hit cycle start there. I got an optional stop in between all of these tool changes. So 1/4 inch Walter end mill here, 4-fluter. This is just a general purpose 4-flute end mill. And I'm gonna turn this coolant off. I just wanna watch it come down and make sure we're not gonna slam into our part there. I think we're good to go. It looks like I had our clearance a little bit high right there as it's coming down into that spiral pattern. That could be improved a little bit, but we got it going. All right, we're gonna turn our coolant on. Adjust that coolant. We'll make sure we're flushing those chips out of there. I believe this is our 2D contour. Sounds pretty good. I think everything's working good here. All right, so that retract and then coming back down into the part, this is gonna be our finish cuts. I believe this is the 2D contour. I'm getting them mixed up. I'm sorry, guys. There we go. Okay. All right, next up is going to be chamfer. Let's turn the coolant off that time. I'm going to bring it down slow, make sure we don't crash it. All right. Oh, look at that. All right. Chamfers look good. So now on to the engraving. All right, how about we do this? We'll, I've got that set at 1/1000th depth. And I'm gonna do the same. I'm gonna bring it down slow, make sure we don't go all the way through the part here with it. Okay. Speed it up to 100. I see some chips. I think we had a good part right out of the gate here. I'm gonna get that cleaned off there. Boy, our engraving turned out great. Chamfer, everything looks good. Tell you what, there's our wrench. Is it gonna fit? It fits. This measures right at 0.625. It's a 5/8 wrench, and I wrote the program to give us an internal hex of 0.627. I wanted to have just a couple thou clearance in that, and it's got a good fit there. All right. Well, I think everything turned out great on that sample piece right there. I think what I want to do is go ahead and I'm gonna do one more here. I might have a good opportunity to get some extra footage there for the video. I'll practice with one more of this, and then we'll move on to our finished piece, which is going to be our 4140. I want to get a good measurement of that internal hex that we're machining there. I just like to see where we're finishing out at. So we designed it to cut to 0.627. So we've got our stair gauge block set out right here. And I started with the 0.5 and the 0.127, so 627. Wouldn't fit. I went down to 626 and it slipped in. So I actually went with 0.6265 on another stack up there, and I think we've got a good fit on our gauge blocks now. Could be another tenth, but this feels really good because I can actually feel it as it's going down in there. So it's probably another tenth because now it's kind of sliding down in there, but that's a good way to measure the internal slot right there using our gauge blocks. I went with the 0.1006 gauge block there, and I think we have an even better fit. You can see that it's holding itself in the slot. A little bit looser at the very top of it, but you can see as we get down in there, you've got just enough friction there for it to hold the block. So I'm going to call this width being 0.6266. I think we've got a great mill program right out of the gate. It's doing awesome. So I'm not going to machine another 1018 cold rolled version. I want to go ahead and switch over to our finish, our 4140, since I'm going to do 3 of those. And we'll go ahead and put one of those in next and start on that. But man, it turned out great. That engraving, the size of the hex, that is wonderful right there. It makes me happy. All right, there's one of our 4140 parts. That's the one that I bought it off in the lathe. Let's hope that all of our cutters and everything performs the same for our 4140. Now I'm going to go ahead and run coolant on this one because I want to make sure I take care of the carbide. And we'll go ahead and get the GoPro fired up here, get you a time lapse, and hopefully we're going to have us another good successful part after this op. This is our first swivel bolt that we machined out of 4140. I think it looks great. The engraving, I think, actually looks even better on the 4140. It really does look good. Got a nice smooth finish. The videos really do usually kind of blow out these finishes and make them look rougher than they really are. I know you can see the tool marks in there, but that Tongue Force Rec does such a good job. It's got such a smooth feel in there. We need to make sure that I'll do a check with the gauge block, but let's see if our wrench fits. And it does, okay? Got the same fit as before. I'll give it a check with the gauge block and see if it changed, if our dimension changed any going into the 4140. But guys, I'm happy with that. It looks good. So on this first one, 4140 that we machined, I did turn our LED work light off. There it is on. So I had that off, and I'm just using my 2 clip lights with some warmer light. And I think it's coming across better on video. It's always tricky getting into these machines with those those really cold LED lights and get a good video out of it. Well, I think this is officially our first swivel bolt, one that we would actually use in a vise right there. Machined out of 4140, and I like it. It looks good. This has turned out to be a great training project for me here in the shop. I was just noticing some of these chips. These are made from our 1/4 inch end mill. They're longer chips for our full depth there. They look good. Those will also bury themselves in your skin, so you got to be careful handling those things. All right, so real happy with the results of our first official swivel bolt that we're going to be using in our vise. It could be this guy right here. So I'm going to go ahead and roll on the next 2 pieces of 4140 since we've got the mill going. Go ahead and get these other guys in there and get them machined. I probably won't fuss with any more of our other sample pieces, our 1018. I've got those over here if I want to come back later for whatever reason and recut it, if we need to prove out some more tools or something like that. So I don't know if it's if I need to get any more video. I got kind of the best I can in here, and you guys have seen it, but I'm going to knock these 2 out, and when we're done with that, we'll go ahead and fit it up over there on the vise, okay? All right, so the mill is over there doing mill things. We've got our gauge blocks. I just wanted to go ahead and check this. I wanted to see if the gauge blocks fit it the same as the soft metal part that we did, or the 1018. This one's got more resistance to it. A little bit more resistance. I need to go hit cycle start so that we can do the milling. It's trying to go in there. I think we're probably going to be about a 1/10 difference. I'm going to swap those out and then we'll check it again. All right, we got a 0.1005 gauge block here. Still feels a little bit snug there. It's going in there, but I can tell it's got a little more resistance. So I think because of the harder material, our cutter must have deflected just very, very minute amount. All right, this one's another 1/10 smaller. This would be 626.4. There we go. Okay, it's slipping in there now. So that would technically be 626.4, 0.626 and 4/10. It feels like it has actually a little bit more, yeah, it's got a little more clearance on the top of the hole and a little less at the bottom. So you can tell that it's got a little bit more deflection there on the top side. Now it's wanting to slip in there. So I know this is really, really getting minute, but I think I'd like to call this one 0.6265 is where this one's going to finish out because of the way that was sliding up and down there. I'm happy with it. I think we have finally come to the end for our swivel bolt project, and I am happy with it. I think they turned out really nice looking. The 4140 always comes through with a beautiful finish and a shine, and all of our machined features on there turned out beautiful. I'm just real happy with the way this looks and the way that it fits, the way that it's going to perform. I think is going to be excellent for this project. So we have three successful bolts there. There we have this was our practice session with the El Cheapo 1018 cold rolled versus the 4140 right there. And then we can even look at the original right here that is shipped with the vise, and you can kind of see the difference there on what we were doing. This is in no way any kind of dig of the quality that they put into the vise or anything. This is simply me wanting to build my own parts like this for a project like this vise here, and making them to my own specifications and making them look the way that I want them to look is all, okay? Nothing wrong with the functionality of the part that comes with the vise right there, all right? I just wanted to make my own, and I'm pretty happy with the outcome. So something that I'd be curious about is if some of you other hardtail vise owners might be interested in one of these A-bomb built swivel bolts there as well. Let me know in the comments. It's very possible we could get us another link to this 4140 and just make a small batch of them. I don't know. So let's go ahead and put it on here and see how it's going to look at the end. Remember that I've still got to machine this recessed area, this counterbore part of the swivel plate. Just want to get the fuzz off of it there. Got our close tolerance bore, 2/1000. So whenever we go to put this together for the final time, when we go to build it, we'll put some grease in there to keep this nice and lubricated for a long period of time. And it'll help it spin there as well. 2/1000 is a pretty close tolerance on this, but I think once everything's sitting flat down the way it was designed, it should function the way it's supposed to. All right, so there it is right there. And then we can take our wrench. I didn't grab that. Let me get that. All right, so here's the fuss with all the wrench. So when we go to install it, we can simply lock it down or loosen it up using an Allen wrench instead of a flathead screwdriver or any other kind of flat instrument. All right, so whenever this is tightened up though, it shouldn't be tightened up on this. That's why I said we still got to machine this, and then so that whenever you tighten it up, this still just pivots on that shoulder in there, or that journal, should I say. So that'll be something that we're going to get to pretty soon there as well, get this swivel plate finished up. But there we go. There's our swivel bolt. It is lower than this face right there, plus it'll drop down further once we machine that down in there and make that look nice. But that looks great. I'm real happy with that. Well guys, this is going to finish up the swivel bolt project here. I'm real happy with the way this turned out. I think it looks good, and I'm real pleased with the fit and finish of everything there as well. Every time I get in there on Fusion 360 and do some training, I'm continuing to learn things that I didn't know before. And what do they say? Practice makes perfect, right? Well, I will say that I have tons of practice to do when it comes to using CAD, CAM, and CNC machines there as well. I have only just begun my learning process of what it takes to understand the fundamentals of being able to draw your own program, make your own programs, and not only that, knowing how to use the machine and how to make the machine run that program the way you want and get the finishes you want and get it on size. So this is this was another chance to work on another CNC project to just help me in the future with my work, okay? I've mentioned this before. CNC is not something that I'm trying to transition into. It's something that I'm simply wanting to add to my level of skills and be able to add that as something that I can do myself here with my shop. You know, manual machining, CNC machining, welding and fabrication, industrial repair, all those things is what I like to do and what I have interest in. And so the CNC side of things is still very new to me, but I want to continue learning it and hopefully getting better and improving. And as I continue that training and that forward progress, I hope that we continue to come up with fun, interesting jobs and projects that we can use over on our CNC machines. This one was a success, but I won't say that they're all going to be a success. This is just another learning job for me right here. But I hope that you enjoyed watching and following along and following my learning process and my journey into the CNC work, and hopefully I'm going to continue to improving it better at it. But more importantly than that, it's all about the Hardtail Vise right here, and this being a very fun shop project for me, and I've been enjoying working on this guy and taking video and sharing it here on the channel with you. So I hope that you continue to come back. We still have several videos ahead of us, plenty more things that we're going to be doing with this vise, and I hope you come back and watch some more of it, okay? We will see you on the next video.